So let's look at 37. Let's say y equals x squared plus 4 to the 10th power and 2x minus 5 to the 8th power. Yes, I can differentiate using the product rule, right? I have 10 x squared plus 4 to the 9th power times the inner function prime times the second function plus the first function to the 10th power, and then I bring 8. I subtract 1 from the power times the inner function prime. This is what's done a long time ago. Here's another way. Apply log to both sides. Okay, if I apply log to the left-hand side, I have to apply log to the right-hand side. X squared plus 4 to the 10th, 2x minus 5 to the 8th. And now I differentiate. You can say, who cares? I know how to differentiate this. Why are you forcing me to do this? I'm not. This is just an example. I'm not going to ask too much of this, okay? But we'll look at this example till the end. Okay, so now I cannot differentiate before I learn implicit differentiation. But we just learned implicit differentiation. We're asked to use logarithmic differentiation, but it will not work if I don't know how to differentiate. I will not be able to complete the problem if I don't understand implicit differentiation. Okay, so I differentiate the left-hand side. Remember, y is a function of x. So how do I differentiate log of a function? Anyone remembers the formula for log of a function prime? Anyone wants to help with a function, log of a function prime? One over y times anyone? No one remembers this formula?
Is it time the function prime?
Very good. Awesome. Now, same thing applies here, right? But before we differentiate, we should apply the rules or properties of log. So let's do that. So log of a product is natural log or log of this plus log of this. I hope you remember these rules. Plus log of 2x minus 5 to the 8th. I did not differentiate anything yet. Then remember, there is a rule that allows us to put the power in front. So this is still, so this is 1 over y dy over dx. Don't put the equal symbol here, please. So 10 natural log of x squared plus 4 plus 8 natural log of 2x minus 5. And now we have this 1 over y times dy over dx. And now let's differentiate these two. 10 will stay outside. How do I differentiate natural log? It's the same way. How do I differentiate natural log of x squared plus 4? We have 1 over x squared plus 4 multiplied by
2x.
Very good. Plus, I don't continue here because I have the page number there. So plus 8. 1 over 2x minus 5 times the inner function prime, which is
2x.
Just 2.
At
Excellent. Perfect. So then again, 1 over y times dy over dx equals 20x over x squared plus 4 plus 16 over 2x minus 5. And now, in order to find dy over dx, all I have to do is multiply both sides by y. And it's done. So dy over dx will be multiplied by y, but I have to use the y that I'm given. I'm not going to write y. I'm going to write this. And you can say, isn't this more complicated? Sometimes it is. I have to agree. So is x squared plus 4 to the 10th, 2x minus 5 to the 8th, times this. 20x over x squared plus 4 plus 16 over 2x minus 5. Now you can say, wait a minute. What's all this? How come is this? Yes, it will be. It will be when we simplify it and we distribute these in here. So, yes, they will be identical, guaranteed. So this is just showing how differentiation, the implicit differentiation can be used if in certain situations, if it's easier to apply log first to both sides and then differentiate. I will not ask you to do this. And if I do, it's not going to have these numbers. I will not. Any questions? Any questions? Is there anything you would like to work on for me to help you with my lab math? Or anything that you would like to work on again from the problems we worked on, similar problems? Or I would like to show the last section of this chapter. Or you want me to go back to any type of problem that you need help with. Does anyone need help with anything? Do you want to work on any problem from what we covered so far?
Honestly, could you just do another implicit differentiation?
Yes, yes, yes. Would you like to choose, or you want me to choose?
You can choose.
So we have, again, I don't know if you can see, but I have on page 359 any of these problems if you want to evaluate or you just want to find the derivative. You want to evaluate, you want me to choose something with evaluate or just the derivative?
Just the derivative, honestly.
Okay, perfect. So here it is. This is 29. Thank you for choosing or selecting a problem. They're asking us to find dp over dx. What does that mean immediately to us? What does it say to us? That p is or is not a variable. That p is or is not a function. If I'm asked to find this, what does this mean what does it say to me? That p is definitely what? A function of x. Absolutely. P is a function of x, guaranteed. Otherwise, they wouldn't ask me to find dp over dx. So I'm going to make the sign under the function. So we differentiate implicitly. Can anyone give us p squared prime, knowing that p is a function of x. How do I write that? We have to quickly say 2p dp over dx. So the function p, 2p to 2 minus 1 times dp over dx. Right away for p squared. Plus
dp over dx.
of course, that's it. Excellent. Plus
2,
excellent. Equals.
0.
That's it. I see 3 terms. 2 of them have the variable. They have to stay on one side, but this one doesn't. But now I cannot combine like terms, so I have to factor. I will factor out the common factor. This is the common factor. Don't erase it like that, you know what I mean. So what do I have in parentheses then?
2p plus 1.
2p plus
Or
1. Exactly, 2p plus 1. So now finally, can anyone tell us what is dp over dx? What does it equal to?
-2 divided by 2p plus 1.
That's it. Can you please upload this or the last page or whatever you have? Let me see if I created the upload. Did I forget or did I create the upload? Oh, I have it there. If you need more time, I'll extend for a few minutes because let me edit it. Just give for a few more minutes just to make sure. If I find my keyboard. I did find my keyboard.